Let us look at proposition number 16 of book 13 of Euclid's Elements. The proposition says to construct an icosahedron and comprehend it in a sphere like the aforesaid figures, and to prove that the square on the side of the icosahedron is the irrational straight line called minor. Okay, let's see how we can understand this. Set out the diameter AB of the given sphere. Cut AB at C so that AC is equal to 4 times BC. Describe the semicircle on AB. Draw CD perpendicular to AB and join DB. Now set out the circle EFGHK with radius DB. So this is the circle, and in this the radius is DB. Inscribe the equilateral and equiangular pentagon EFGHK in the circle EFGHK. So let's draw the pentagon, and we'll name its vertices as EFGHK itself. Bisect the circumferences EF, FG, GH, HK and KE. Draw LM, MN, NO, OP, PL. We have already done that. But we also have to join EP. Okay, so we have joined EP. So here pentagon LMNOP is also equilateral. EP belongs to the decagon. Here it says EP belongs to a decagon, but more specifically, it belongs to the decagon inscribed in this circle. Because if we join E, L, F, M, G, N, H, O, K, P, E, then we would end up with a decagon, and EP is one of its sides. Now, construct EQ, FR, GS, HT, KU perpendicular to the plane of the circle EFGHK, such that its heights are equal to radius of the circle. Now draw QR, RS, ST, TU, UQ. We also have to join QL. Where is L? We have to join QL, LR, RM, MS, SN, NT, PO, OU, UP, and PQ. Now here EQ is parallel and equal to KU because they both are perpendicular to the same plane. So that means QU is also parallel and equal to EK because they are joining the endpoints of EQ and KU. Now EK belongs to the equilateral pentagon inscribed in EFGHK circle, which means QU is also belonging to the equilateral pentagon in circle EFGHK. Similarly, we can show QR, RS, ST, TU also belongs to the equilateral pentagon in circle EFGH. So, which means QRSTU is an equilateral pentagon. Now, angle QEP is right angled. So, that means QP square is equal to QE square plus EP square. So, QP belongs to a pentagon. How did we arrive at this? Because remember, EP is the side of a decagon and QE is the side of a hexagon, because QE is equal to the radius of the circle EFGHK. So if we have a right angle triangle whose one side is equal to the side of the hexagon and the other side is equal to the side of a decagon inscribed in the same circle, then the hypotenuse will belong to a pentagon. So EP decagon, QE hexagon, that means QP is pentagon, is the side of a pentagon. Similarly, we can show that PU also belongs to a pentagon. So that means QP, PU, and QU, all three belong to the pentagon inscribed in this circle, EFGHK. That means they are all equal to each other. So triangle QPU is equilateral. Similarly, we can show the triangles QLR, RMS, SNT, TOU. They are all equilateral. Okay. Now, QL, QP, and LP belongs to a pentagon. So, which means again, triangle QLP is equilateral. So, similarly, we can show triangles LRM, MSN, NTO, OUP. They are also equilateral. So, basically, what we have shown is that all the triangles that we can see here are equilateral. Now, let's take the center of the circle EFGHK as V. Now, set VZ perpendicular to the plane of the circle EFGHK and extend it in the other direction to X. Now, cut VZ at W such that VW is equal to side of hexagon. Side of hexagon is QE. WZ is a side of decagon, that is EP, and VX is equal to the side of decagon, that is EP. QZ, QW, UZ, EV, LV, LX, XL. And just let's keep going and add all these lines as well. That is NX, OX, PX, SZ, TZ, RZ, so that it's difficult to make out, but what is required, the icosahedron has been constructed. Later on, I'll clarify this diagram so that you can clearly make it out. Okay. So now VW is parallel and equal to QE. Since EV belongs to hexagon, so does QW. Because this is the radius of the circle, that means it is the side of the hexagon, and QW will also be the side of the hexagon or belongs to hexagon. Since WZ belongs to decagon and QWZ angle is right angle, that means QZ belongs to a pentagon. Similarly, we can show that UZ belongs to the pentagon. Since QU, UZ and QZ all belong to the pentagon, that means triangle QUZ is equilateral. Similarly, we can show that triangles UTZ, TZS and SZK, they are all equilateral. I know it's difficult a little bit to figure out this. Now, VL belongs to a hexagon. Where is VL? L here. And VX belongs to a decagon, or belongs to the decagon. and the angle LVX is a right angle triangle. Remember, LV is perpendicular to VX. So that's why it is a right angle. That means LX belongs to a pentagon. Similarly, we can show that MX belongs to a pentagon. That means triangle LMX is equilateral. Similarly, we can show that triangles MNX, NOX, OPX, and PLX, they are all equilateral. So that means an icosahedron has been constructed containing 20 equilateral triangles. So these 20, 5 is at the top with the vertex at Z, and another 5 is at the bottom with X as the vertex, and around the circle you have 10. So 5 plus 5 plus 10, 20 equilateral triangles we have. So we have constructed the icosahedron. So now I've hidden practically everything except what is absolutely essential, and this is how the icosahedron looks like. So that is the first part of the proposition. Now let's look at the second part. Here, VW belongs to a hexagon. VW belongs to a hexagon and WZ belongs to a decagon. That means VZ is cut in extreme and mean ratio at W, where VW is its greater segment, which means ZV is to VW is equal to VW is to WZ. We know VW is equal to VE and WZ is equal to Vx. So that means ZV is to VE is equal to EV is to Vx. And angle ZVE is right angle and EVX is also right angle. That means triangle XEZ is similar to VEZ. I have not purposely joined E and Z, then it becomes too messy. So since these two are similar triangles, that means angle XEZ is right angle. Since it is right angle, ZV is to VW. Yes, VW is to WZ. So we know ZV is equal to XW and VW is equal to WQ. So that means this proportionality becomes XW is to WQ as QW is to WZ. Well, XWQ, XWQ and QWZ are right angles. So that means triangle XWQ is similar to QWZ. And since they are similar triangles, that means XQZ is also a right angle, which means that a semicircle on XZ will pass through Q. So let's see whether it passes or not by drawing it. Yes, it is passing through Q. XZ remaining fixed, the semicircle is carried round and restored to the same position from which it began to be moved. Then it will pass through Q and the remaining angular points of the icosahedron. That means it will pass through R, it will pass through S, it will pass through T, it will pass through U and back to Q. Similarly, it is passing through E now. And if we take it around, it will pass through F. It will pass through G. It will pass through H. It will pass through K. That means that this sphere that we end up with would be the sphere in which this icosahedron has been inscribed. So we have visualized. So let me draw the sphere itself just to show you, because then I'm going to remove it. Otherwise, it becomes difficult to understand the various lines. So this is how. See, it may look as if Z is not on the sphere. It is actually. The only thing is it's a little bit tilted. That's why it looks like that. Okay, so let's make it disappear. Now let's continue, because now we have to figure out one other aspect that the proposition says, that the side of the icosahedron is the irrational straight line called minor. So what we do is we take VZ and cut it in extreme and mean ratio at W, and ZW is the lesser segment and VW the greater segment, which we have already done. Everything is there. Now, based on one of the previous propositions, we can say ZW plus half of VW. So which means we have to take the center, midpoint of W and B. So A prime is the point which bisects VW. So ZW plus half of VW, the whole square, is equal to 5 times half of VW square, which basically means ZW plus half of VW. ZW plus half of VW is WA prime, which is nothing but ZA prime. So ZA prime square is equal to 5 times half of VW. Half of VW is A prime W. So A prime W square. Now, ZX is equal to 2 times ZA prime. Why? Because remember, A prime is the midpoint of VW, and we know ZW is equal to VX. They are both equal to EP. They are both the side of the decagon. So that means ZX is equal to 2 times ZA prime. And VW is equal to 2 times A prime W. So that means ZX square is equal to 5 times WV square, because these are nothing but multiples of ZA prime and A prime W. And we know AC is 4 times BC. And if we add BC to AC, then AB will be 5 times BC. And we also know that AB is to BC is equal to the square on AB is to square on BD. Now, since AB is 5 times BC, that means AB square is also 5 times BD square. Now, since BD is equal to VW, which is equal to radius of circle EFGHK. Remember, our construction was that we draw a circle of radius BD. So that means AB is equal to XZ. Why? Because AB square is equal to 5 times BD square, ZX square is equal to 5 times WV square, and BD is equal to WB. So since these two are equal, that means AB square is equal to XZ square, which means AB is equal to XZ. And AB is the diameter of the given sphere. That is how we began. That means XZ is also the diameter of the given sphere. Now, AB is rational, and we know AB square equal to 5 times BD square, which is equal to radius of the circle EFGK square. AB square is equal to 5 times BD square. which is equal to 5 times radius of the circle EFGHK square. So radius of the circle EFGHK is rational, which means diameter of the circle EFGHK is rational. So remember, side of the equilateral pentagon inscribed in a circle which has a rational diameter has the side as minor, and side of the pentagon EFGHK is the side of the icosahedron. That means the side of the icosahedron is the irrational straight line called minor. So we have constructed an icosahedron and visualized it in a sphere, in a given sphere, and we have proved that the square on the side of the icosahedron is the irrational straight line called minor. So that is proposition number 16 of book 13 of Euclid's Elements. Again, let me remind you, there is a link to a PDF book which describes all these propositions in detail. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share. That's it for now.